Consciousness isn't just a mystery to be puzzled over. It might actually be woven into the fundamental fabric of the universe itself. Imagine a world where your awareness isn't separate from the cosmos, but a tiny thread in its vast, intricate tapestry. Today, we're diving into a mind-bending idea that consciousness could have a quantum nature, connecting us across space and time in ways science is just beginning to understand. If you've ever wondered whether your mind is more than just a byproduct of biology, if it's a part of the universe's deepest architecture, stick around, because what we're about to explore might change the way you see everything. The foundations of consciousness and quantum mechanics. Proponents of quantum consciousness suggest that the mind's most profound mysteries might be rooted in the peculiar behaviors of quantum physics, which govern particles at the tiniest scales. Unlike classical physics, which assumes objects have definite states and can be measured without altering them, quantum mechanics introduces concepts like superposition and entanglement. Superposition allows particles to exist in multiple states simultaneously, collapsing into a single outcome only when observed. Entanglement links particles so that the state of one instantly influences the state of another, regardless of distance. These phenomena challenge our everyday understanding of reality and raise the possibility that similar principles could underpin consciousness itself, especially given the complex, interconnected nature of neural processes. The idea of quantum coherence within biological systems has gained some scientific traction in recent years. Researchers have observed certain biological structures, such as photosynthetic complexes, exhibiting quantum coherence that enhances their efficiency. This suggests that living systems can, under specific conditions, sustain quantum states despite the disruptive influence of their environment. Applying this to the brain, some theorists argue that microtubules, structural components of neurons, could serve as quantum information processors. These microtubules might maintain coherent quantum states long enough to influence neural activity, potentially linking quantum phenomena directly to the emergence of conscious experience. If true, this could turn the traditional understanding of cognition inside out, viewing the mind not solely as a classical computation, but as a quantum process intertwined with the fabric of the universe. Quantum mechanics also hints at a fundamentally interconnected universe, where separations between objects are less entrenched than they appear. In this view, consciousness may not be an isolated feature of brains, but an integral part of a universal quantum field. Such a perspective aligns with notions from certain interpretations of quantum physics, like the many-worlds or relational quantum theories, which see reality as a web of entangled states rather than independent entities. From this standpoint, conscious awareness could result from the same underlying quantum processes that connect particles across vast distances, implying that consciousness might be a universal, non-local phenomenon embedded within the quantum substrate of reality. This line of thinking also challenges the classical view that consciousness arises solely from complex neural computations. Instead, it suggests that the mind could be a manifestation of quantum informational processes permeating the universe. While traditional neuroscience focuses on synaptic activity and electrical signals, quantum consciousness theories speculate that the true source of subjective experience might involve the delicate interplay of quantum states preserved and manipulated within neural microstructures. Although empirical evidence remains limited, this intersection between consciousness and quantum physics provides a fertile ground for rethinking the nature of mind and reality, pushing the boundaries of how we understand our place within the cosmos. Evidence and theories supporting quantum consciousness. Quantum consciousness remains a provocative frontier in neuroscience and physics, driven by the intriguing overlap between quantum mechanics and cognitive phenomena. One of the core pieces of evidence cited by advocates of this theory is the extraordinary coherence observed within neural microtubules. These microscopic structures inside neurons are thought to facilitate quantum states that remain surprisingly stable, despite the warm, wet environment of the brain. This stability is crucial because conventional wisdom suggests that quantum states rapidly decohere in such conditions. But some researchers argue that microtubules might act as natural quantum processors, enabling rapid information transfer and complex computations that classical models struggle to explain. A significant theoretical framework supporting this idea is orchestrated objective reduction, orchestroir, proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. They argue that conscious experience arises from quantum superpositions collapsing within microtubules, effectively grounding consciousness in fundamental physics. The orchestroir model predicts that quantum effects could influence neural activity at a macro scale, producing the unified, subjective experience we associate with consciousness. While the model remains controversial and debated within scientific circles, its predictions have inspired experimental efforts to detect quantum coherence in neural tissue. These experiments utilize advanced spectroscopy techniques, seeking to observe quantum states or entanglement signatures within brain tissue. Further supporting this line of inquiry are recent developments in quantum biology, where phenomena such as photosynthesis and bird navigation have been shown to involve quantum coherence and entanglement. These biological processes demonstrate that quantum effects are not limited to the realm of exotic physics, but can play functional roles in living organisms under natural conditions. If quantum coherence can persist in delicate biological systems to facilitate energy transfer or sensory processing, the possibility that consciousness also leverages similar mechanisms begins to seem less far-fetched. Experimental evidence of sustained quantum states in biological environments bolsters the argument that the brain might similarly harness such phenomena, hinting at a deeper quantum underpinning of conscious awareness. In addition, certain anomalous experimental results challenge purely classical explanations of cognitive phenomena. For example, some studies have reported that neurons can exhibit behaviors best explained through non-local or quantum-like models, such as instant correlation across vast neural networks or decision-making processes that defy classical probability theory. While these findings are still subject to debate and verification, they suggest that quantum principles might be woven into the fabric of mental processes, rather than being mere mathematical metaphors. It's this convergence of experimental anomalies, biological insights, and theoretical models that makes the case for quantum consciousness compelling for a growing segment of scientists and philosophers alike. Implications of a quantum consciousness for our understanding of reality. The idea that consciousness might have a quantum foundation challenges many traditional perspectives rooted in classical physics and neuroscience. Instead of viewing the brain as a purely mechanical system operating via neural networks and biochemical signals, some theorists propose that quantum phenomena, such as superposition, entanglement, and coherence, could be integral to conscious experience. This perspective suggests that our minds are interconnected with the fabric of the universe at a fundamental level, rather than being isolated computational structures. For instance, experiments in quantum biology, like quantum tunneling in enzyme reactions or coherence in photosynthesis, demonstrate that quantum effects can occur under biological conditions, hinting that the brain's complex architecture could support similar phenomena. If consciousness is indeed influenced by quantum effects, it radically shifts how we interpret perception, free will, and subjective experience, connecting them to the fundamental laws that govern the universe at its smallest scales. Considering the implications for how we understand reality, a quantum view of consciousness introduces the possibility that observation and measurement play a more profound role than traditionally thought. In quantum mechanics, the act of observation collapses superpositions into definite states. If consciousness itself is fundamentally quantum, then our awareness might be involved in shaping reality, not just passively perceiving it. This leads to a universe where the boundaries between observer and observed are blurred, and the act of conscious observation influences the very structure of reality, echoing ideas suggested in the participatory universe concept. Such a framework aligns with certain interpretations of quantum mechanics that emphasize the importance of information and consciousness, rather than purely objective, detached phenomena. Furthermore, a quantum consciousness could offer explanations for some of the most puzzling aspects of human experience: near-death experiences, déjà vu, or instances of ostensibly precognitive intuition. If entanglement links consciousness across space and time, then information might not be strictly localized within the brain, but could be part of a larger, interconnected quantum field. This could account for why some individuals report experiences that seem to transcend physical boundaries, operating on a level of collective or universal awareness. It opens new pathways to understand phenomena that are otherwise dismissed or misunderstood within the limitations of classical physics. Essentially, it invites a view of reality as a holographic, interconnected web in which consciousness is not merely an emergent property, but a fundamental component, potentially influencing the universe at its most elemental level. Finally, embracing quantum aspects of consciousness has profound implications for our understanding of free will and the nature of choice. If thoughts and decisions are influenced by quantum indeterminacy, then the universe might not be entirely deterministic. Instead, there exists room for genuine spontaneity, creativity, and agency that originate from the quantum level of reality. This aligns with philosophical debates about whether free will can coexist with natural laws, suggesting that the very fabric of consciousness might make possible a universe where novelty and genuine choice are fundamental features rather than illusions. It prompts us to reconsider what it means to be conscious, to exert control, and to participate actively in shaping our experience and, perhaps, the universe itself. Challenges and future directions in quantum consciousness research. Understanding the challenges facing quantum consciousness research requires grappling with both the scientific complexities and the philosophical implications inherent in the idea that consciousness might be rooted in quantum phenomena. One primary obstacle is the difficulty in experimentally validating claims about quantum effects in the brain. Unlike quantum particles in controlled laboratory settings, neural processes are warm, noisy, and macroscopic, which historically suggests that quantum coherence should rapidly decay. Yet, some scientists argue that certain brain structures, like microtubules, might sustain quantum states long enough to influence conscious experience, but direct evidence remains elusive. Developing sensitive, non-invasive techniques capable of detecting such fleeting quantum states in living neural tissue is a major hurdle. Theoretical models tend to face similar struggles. Many propose that quantum entanglement or superposition could underlie aspects of consciousness, but there's limited consensus on how to mathematically formalize these ideas within the complex architecture of the brain. A significant challenge involves bridging the gap between quantum mechanics, which governs atomic and subatomic scales, and classical neurobiology. Researchers working within quantum biology have found intriguing examples, such as avian navigation or photosynthesis, where quantum effects seem to play functional roles in biological systems. Extending these insights into the realm of consciousness involves dealing with a host of unresolved questions about decoherence, measurement, and the nature of quantum information processing in living systems. Future directions might involve interdisciplinary approaches that combine advances in quantum physics, neuroscience, and computational modeling. Quantum-inspired algorithms and simulations could serve as proxies to test hypotheses about how quantum effects might influence neural activity. Additionally, emerging technologies like quantum sensors and cryogenic neuroelectronics offer potential pathways to detect quantum states within biological tissues more precisely. Building experimental frameworks that can isolate potential quantum signals from the noise of classical neural activity will be crucial. On a broader scale, the philosophical implications of discovering quantum foundations of consciousness demand rigorous debate, challenging our understanding of free will, self-awareness, and the interconnected fabric of the universe. Overall, tackling these challenges demands collaborative effort across disciplines. As experimental techniques mature and theoretical models refine, the hope is that quantum consciousness research will provide not only answers about the nature of awareness, but also deepen our perception of reality itself. The road ahead involves confronting the mysteries of decoherence, measurement, and information transfer in biological systems, areas where the boundary between physics and philosophy blurs, inviting endless curiosity and exploration. The idea that consciousness may possess a quantum basis posits that traditional biological and neurological explanations might be insufficient to fully understand the phenomenon. Instead, consciousness could emerge from the behavior of quantum entities within the brain's microstructures. Quantum phenomena such as superposition, entanglement, and tunneling, often associated with particles at the atomic and subatomic levels, offer a framework for considering how information processing in neural substrates might transcend classical mechanisms. Certain structures within neurons, like microtubules, have been hypothesized to act as quantum information processors, potentially enabling non-local correlations and complex computational processes. Supporting this idea, experimental evidence from quantum physics shows that entangled particles remain connected over long distances, exhibiting correlations that cannot be explained by classical physics alone. If similar mechanisms could operate within the brain, then the collective quantum states could influence how consciousness is experienced and how different parts of the brain communicate instantaneously. This could account for phenomena like the unity of conscious experience and the rapid, seemingly non-local integration of sensory input. Some scientists argue that quantum coherence could persist within the warm, wet environment of the brain, a challenge to earlier assumptions that decoherence would prevent such phenomena from influencing neural activity. Critics point out that demonstrating quantum effects at the neural level remains a formidable challenge. The brain's environment is inherently noisy and prone to decoherence, which would typically suppress quantum states very rapidly. Nonetheless, advances in quantum biology, such as studies on quantum effects in photosynthesis and enzyme reactions, show that quantum phenomena can operate in biological systems at room temperature. This opens the door to plausibility. Perhaps the brain has evolved specialized mechanisms to preserve coherence or exploit quantum effects for quantum-enhanced information processing. A further intriguing aspect of the quantum hypothesis of consciousness involves the notion of the universe itself being interconnected through quantum entanglement. If consciousness arises from quantum states that are inherently non-local, then our sense of individual separateness might be a manifestation of classical limits rather than fundamental reality. This aligns with some interpretations of quantum mechanics, suggesting that the fabric of space-time and consciousness could be intertwined at a deeper level. In this view, consciousness is not merely a byproduct of neural activity, but an integral part of the cosmic quantum structure, one that challenges purely materialistic or classical explanations and invites us to reconsider the universe as a seamless, interconnected whole. As we wrap up this exploration into the quantum nature of consciousness, it's clear that the idea challenges our traditional understanding of mind and universe as separate entities. We've seen how quantum phenomena, entanglement, superposition, and coherence might play a role in shaping conscious experience, hinting at a deeper connection woven into the very fabric of reality. If any of this resonates with you, it's worth pondering how these concepts could revolutionize the way we see ourselves and the universe around us. Remember, this is just the beginning of a much larger conversation. In future videos, we'll dive deeper into the scientific experiments, philosophical implications, and potential technological breakthroughs that could stem from understanding consciousness at a quantum level. If you're curious about what's next, make sure to subscribe and stay tuned. Thanks for joining me on this mind-expanding journey. Your curiosity is what keeps this exploration alive. Until next time, keep questioning, keep imagining, and keep dreaming about what lies beyond the limits of our current understanding.